layer, you can do the enforcement there, because where your assumption of trust comes into play is at your BIOS. So you're assuming that that is trusted, okay, and trustworthy. Now, if it is somehow compromised, because it is not in the TPM, you know, everything goes out of the water there. But if at each layer, the layer below it, at the preceding layer, evaluates the integrity of what it's loading, then you can control, compromise entering at that point. So, you're correct. If you're not doing that kind of strict evaluation of what you're loading, you can load something malicious, and then that malicious layer can hand off anything else. So, that becomes the problem. But you will want to evaluate that as you're loading it. Yeah.
My question would be regarding the trusted module. What is actually preventing me from emulating the whole trusted module from the host system itself?
So one of the problem that how do I begin to detect that you're actually emulating and you're not the real TPM? Okay, has to do with the actual key itself.
I mean, let us say that I have not had any prior communication with the remote server that I'm thinking of establishing a communication with.
Okay.
And I emulate a completely new TPM with a new set of keys.
And if you get a certificate authority to certify that this key is associated with the TPM and this is a real TPM, but the TPM's endorsement key itself is certified by the vendor. Okay. So that's where you get in. That's where you remember when I talked about this whole notion of social trust. Okay, your social trust is relying on the vendor. So the vendor is included in this verification chain based on its certification that this public key, private key pair is for a TPM that I created. So any identity key that's generated has to then be, signed by this particular key. So you create a key chain. So that's what prevents you from just saying, okay, I'm just going to be my own TPM. I'm going to emulate all this functionality. Is because you're relying on the vendor, to provide a level of certification for that chip.
And I just had another question. You'd also said that every time an OS loads, the state is first recognized by the TPM and then it's allowed to load. Now, you said that this state would also depend on the policies that have been preset, because what are the applications that will be loaded with the application is dependent on the policies. So now, let us say, I have a keylogger. Let's keep it as simple as that. And there is a policy which says that load this application. The policy engine basically doesn't know anything about it. It just thinks that this is another application that we loaded with the OS. Now, wouldn't it make sense to separate the policy engine from the host or from the TPM so that it's more secure?
To separate the policy engine from the TPM and from the host so it is more secure. Okay, so I think I lost, you said that the policy engine doesn't say anything about loading. It just says, let's say, for example, I'm trying to understand your question. Let's say your policy engine says that load every application.
Oh, no, the policy engine doesn't know that, this is a keylogger which is basically malicious, neither that is TPM. But the TPM depends on the policy engine basically to verify any new application that is supposed to be loaded with the operating system. So considering that you have changed the policy engine, which is a part of the host now, and the TPM trusts the policy engine for the keylogger to be loaded, wouldn't it make sense that the policy engine is separated from these two so that even that could be trusted?
Okay, so so let me ask this question. So are you saying that we have a policy engine that's a part of, let's say it's a part of the OS?
Okay.
Okay, so the policy engine is a part of the OS. And are you saying that your policy engine is compromised somehow?
It could be, yes.
Okay, so let's say your policy engine is compromised. And so that means your OS is compromised. Okay, and now you're just loading keyloggers and your system is in a compromised state. Now, in the example of remote verification, a remote entity can determine that, okay, if it's requesting quotes from you and it has some predefined state, it can determine that you're no longer running what you expect it to run.
Okay.
You know, so you can verify that, but what you cannot verify locally is that you may be in an untrustworthy state. Now, if I said like your policy is embedded within those software stack, at each layer you know what you're supposed to run. Now, you would, before your loader loaded your OS, there's a part of the policy engine in each layer, so it knows what it expects to, load. So you shouldn't, if you have a specific policy on which OS to load, you shouldn't load the compromised OS. So that becomes, part of the issue, because you have what is constituted as a trusted entity loading an untrusted, something that is not trusted. Okay, so then that becomes an issue. I don't think so you have not the full policy engine in one particular piece, but there's a piece in each layer to tell it what your images look like that you're supposed to load at this point. So that's where it's not all in one particular place where the OS controls everything that should be loaded. But once your OS is in a compromised state, then you have a problem, and you won't be able to detect that until some remote entity verifies the integrity of the system.